All right, this question is quite interesting because they're asking us to find two things. So, they're asking us to find the area at two different time, at two different moments. So, I'm gonna read the question first. So it says the radius of a circle or a circular or lake expand at a rate of 2 meters per second. So basically, what I'm saying that the radius here, the radius is expanding. So I have a circle which is getting bigger and bigger, right? So I have a circle that is getting bigger and bigger. So the radius, so if my radius was first this, so from here to here, and then the radius is expanding again, and then it's expanding again here. So they're telling me that this radius r, my radius r, is expanding at a rate of 2 meters every second. So every minute, So every minute my radius is increasing. So every 2 minutes. So basically my radius is expanding every 2 minutes. That means that the radius is changing every 2 minutes, which when I think about that, what comes to my mind is the rate of change. So the rate of change of something just tells me the slope. So how the rise and over the run will give me the slope. So here I can immediately come to the conclusion that when the first sentence here, the rate of change of the radius gives me the r prime, which is the same as dr dt, because as you can see, we're changing every 2 minutes. We're changing the radius 2 meters every minute, right? So with that in mind, I come with r prime is equal to 2 meters per minute. So what's the next thing? They're asking me to find how fast is the area of the oil slick increasing when the radius is 25. So they want to find when my radius is 25. So my radius is 25. What is the area, the change in the area? So here we need to understand what is the relationship between the radius and the area. What is the relationship between them? Okay. The relationship between the area and the radius is a is equal to pi r squared, because the area of a circle will give the area of a circle can be found using the radius squared times pi. Knowing this, now I can find a prime, or this is the same as dA dt. So what is dA dt equal to? So dA dt is equal to the derivative of this whole set. Remember that we were considering r as a function because r is changing because of time. So basically this is the same as r of t. So now I want to find what is the derivative of the radius. We want to find what is the derivative of this side of the equation. If we're considering that r is a function, we're going to find the derivative of r as if it was a function. So this means that I'm going to say let r is equal to f of x, or let me say f of t. Because now with this, what I did is I'm saying, oh, I'm considering r as a function. So if I have to find the derivative of f of t like this, what would that happen? I would do 2, because I would use the chain rule, because I'll use the 2 down here. So 2 times f of t multiplied by the derivative of what is inside. Why did I do that? Because I have a function inside of a function, right? So let me just use f of t instead of using f of x. So this, remember that I say that r is the same as f of t. Then I can rewrite this as 2r times r prime. This is the derivative of this side of the equation. Remember that pi is a constant. It's multiplying this whole thing. So that means that I'm just going to go back with the same pi. So now dA dt, which is the same as a prime, is the same as pi multiplied by what we just found, the derivative of this side. So 2 times r times r prime, which is the same as dr dt. Now I want to find what is the change in of the rate of the area when my r is 15. Remember, because that was the first question when my r, when my r is 25. Let me just make sure that. So here, when the radius is 25, what is the change in the area? How fast is the area changing? So with all of this information that I have, I can find what is dA of dA dt is. So I know that my r is 25, and I remember that dr dt, that was the first thing we found. We say that dr dt was 2 meters per minute. I can come down here and write it all down, put them all together. So dA dt is equal to pi 2 times 25 times 2. So the 2 is r prime, which is the same as dr dt. Sorry for my bad handwriting here. And the 25 is the radius at that exact moment. I hope everything is making sense so far. So now, what is dA dt? We can multiply everything. So I have 2 times 25 gives me 50. 50 times 2 give me 100. 100 times pi give me 100 pi. You can put in a calculator and you get the exact answer with some decimal numbers in it. So this one was my first question. So now this was A. Now I want to find B. Right? So if that was A, now I want to find what B is. So my question for B is, if the radius is 0 when the time is 0. So if r is equal to 0 when t is equal to 0, that's the first thing I have. How fast is the area increasing after 3 minutes? So after 3 minutes, what will my r be? That is something I need to figure out. For this one, we can use a simple trick. If I know that the rate of change of the radius, so r prime is 2 meters per minute. Sorry, is 2 meters per minute. So after 1 minute, let's do this. So what would my radius be after 1 minute? So after 1 minute, so my radius is changing like this over minutes. After 1 minute, my radius would be 2 meters. After 2 minutes, I'm multiplying the 2 meters times the meters times the minutes, after 2 minutes, because I want to get rid of this. What will happen is that my radius will be 4 meters, So 4 meters, so many m. After 3 minutes, if my radius is still changing at this rate of meters over minutes, after 3 minutes, my radius would be 6 meters. So now with this information, and I already know with this information, I would have to find how fast the radius, how fast is the area changing, meaning here they say increasing, after 3 minutes. So after 3 minutes, I know that my radius is not going to be 25 anymore, but it's going to be 6. Going back to everything that I know from the previous example, from the previous work we did, we know that to find the dA dt, so if you want to find dA dt, we found out that it was pi times 2 r dr dt. So now with my new radius, I can just put it here. So I have dA dt is equal to pi times 2. What is my radius again? My new radius is 6, and my dr dt is the same throughout. So I have 2 times 6 times 2. This gives me 4 times 6. What does 4 times 6 give me? Give me 24. So I have 24 pi. So dA dt after 3 minutes is equal to 24 pi. And that is how I solve this.